Okay, so now our task is to find the prime factorization. I've given you 4 numbers to do that for. So number 1 was the number 70. And the steps that I gave you were to use a factor tree in order to find the prime factorization. So that is exactly what we're going to do. We're going to start by making a factor tree for the number 70. Okay, and you may remember this from middle school, but it's still going to be useful even now that you are in high school. So the number 70, what do we know about the number 70? It ends in a 0. And one of the nice things about revisiting prime factorization and factor trees is that we also get to revisit divisibility. Anything that ends in a 0, we can divide anything that ends in a 0 by 10. Anything that ends in a 0 we can divide by 10. So 70 divided by 10 is 7. And we know, so right now we have 2 leaves of our factor tree. Okay, 10 and 7. And 7 is a prime number. So we're going to leave 7 because that can't be factored. You could say it's factored into 1 and 7, but we're not going to do that. It's a prime number. We can't divide it by anything but itself and 1, so we're done. Okay? 10, however, 10 is 2 times 5. Okay? 10 divided by 5 is 2. 10 divided by 2 is 5. So now we actually have all of the leaves of our little factor tree here. We've got 2, which is a prime number, 5, which is a prime number, and 7, which is a prime number. So now we can come up with our prime factorization. Our prime factorization says that 70 is 2 times 5 times 7. Okay? And the nice thing about prime factorizations, as opposed to regular factorizations, is that prime factorizations give you the numbers that the product of which is your number. 2 times 5 is 10. 10 times 7 is 70. This is our prime factorization. Okay, our second number is 210. Let's take a look at 210. Okay, 210. Again, look at that. We've got another 0. So we're going to be able to divide this by 10. 10 times 21. Okay, notice 21 and a 0. 21 times 10. Just like this was a 7 and a 0. 7 times 10. Okay, are either of these prime numbers? No! 10 is once again 2 and 5. And 21 is 3 and 7. Are these all prime numbers? Well, yes, in fact they are. So we have our leaves. So our leaves for 210 are 2, 5, 3, and 7. Which means that we can say that the prime factorization of 210, I'm going to write it underneath here, 210 is equal to 2 times 3 times 5 times 7. And the thing to recognize here is that generally speaking, we are going to start with the lowest number and end with the largest number. So let me go ahead and fill these in. 70 is 2 times 5 times 7. And 210 is 2 times 3 times 5 times 7. Okay? All right. Number 3, our third one. Let's see if I can move this whole thing back. Nope. All right, yeah, sure I can. Okay. Number 3 was 168. Okay, so now we've got a number that can't be divided by 10. Okay? This ends in an 8 rather than a 10. One thing that we know about 8 is that it's an even number, and any even number can be divided by 2. So let's divide this by 2. 168 divided by 2. 16 divided by 2 is 8. So 160 divided by 2 is 80. 8 divided by 2 is 4, so this is going to be 2 times 84. 84, oh, looks like we've got a leaf here. Okay, let me go ahead and, I'm using green because it's a leaf. 84 also can be divided by 2, right? 84 is going to be 2, and it looks like 42. Looks like I've got another leaf here. Okay. Remember, the prime numbers are our leaves. 42 looks like 2 times 21. Okay, another 2 and 21. So we've got the prime number, whoops, okay, prime number of 2, and 21, of course, is 3 times 7, just like it was for my other one. Okay, so 3 times 7, and I'll put these last leaves out. And now I'm going to say that in this case, notice I've got 3 of the same number. With a prime factorization, we're going to include all 3 of those. So let's go ahead and go back to black. We'll move this, and I've got 2 times 2 times 2 times 3 times 7. And a lot of times you'll see that written as 2 to the 3rd power times 3 times 7. Again, prime factorization, because 8 times 3 is, well, let's go backwards. 3 times 7 is 21. 21 times 2 is 42. 42 times 2 is 84. And 84 times 2 is 168. So you notice what we're writing here is we're not just saying what are the factors. The prime factorization means that we are expressing this number as a multiplication expression that is literally the same value. And our last one, of course, we're going to look at 2520. Okay? So I'm going to make myself a factor tree of 2520. I think I'm going to make this in a different color so I don't get confused. 2520, okay? Look at the 0. This is going to be 10 times 252. This has a 2. Whoops. This has a 2. That means that I can divide this. If it were 250, it would be 125 times 2. So since it's 252, it's going to be 126 times 2. Okay? By the way, 10 is 2 and 5. 126 looks like is 2 times 63. And we know that 63 is 9 times 7. And that 9 is 3. Whoops. 3 times 3. So look, let me go ahead and pull that green out again. And I have my leaves. They're all prime numbers. Okay, so 2520 is going to be the same. It's going to be equal to 2 times 2 times 2 times 3 times 3 times 5 times 7. Okay, so those are our prime factorizations.